Today, we're going to start a new topic, which is project time management. This is one of the triple constraints of projects, and also this is one of the knowledge areas that we talked about in chapter 3, chapter 2 and chapter 3. These are important and core activities or core knowledge areas: time, scope, cost, and quality. These are the core knowledge areas, and then the rest are the facilitating or supporting activities. Okay. In time, now we know that time is valuable and it is the least flexible resource in any project, because when time passes, you cannot go back. No? This is not just in projects; it's in scheduling. In scheduling projects, one of the most issues that you will receive or that makes conflicts in the project is timing. Okay. When you plan the schedule, things are fine. When you start executing the schedule, any bad things are good. But once you reach to more sophisticated levels in your work, say in the half of the project, in the middle of the project, then things start, because you have these small delays here and there, and then this will all accumulate, and then problems will arise, and then you will see that you have problem in meeting the goals and delivering on time. So that's why time is an important area that we need to place good attention, especially in planning. So when you plan for the project time or schedule, you should consider many things, and keep in mind also that we mentioned earlier this point that when you plan, you keep in consideration not just the time knowledge area, you keep in your mind also the cost knowledge area, the scope knowledge area, quality knowledge area. All the knowledge areas has to be in your mind at that time. So it's like it's an overlapping stage that all the knowledge areas has to be looked at. In project time management, we have 7 processes, similar to other other knowledge areas. They have some activities. This is, I think, the longest. It has 7 processes, and here is just a brief explanation about them. So planning, schedule management, defining activities, sequencing, estimating activity resources, estimating activity durations, developing the schedule, and controlling the schedule. Now, from the names, it's obvious. You can see what does this mean. No? But we'll go back through them and we'll go into some details. Notice that most of or all the knowledge areas have a planning process. It always starts with the planning process. In the scope, we have planning scope management. In time, we have planning time management or planning schedule management. In cost, the same thing. You will have planning cost. So we always have a planning process. And as I also mentioned earlier, that the output of this plan process in all of these knowledge areas will be considered as a subset of the overall project management plan. They might be in separate documents, or they are part of the complete project management plan, which I refer to also the master plan of the project. Okay, master management plan. Okay, so if we look at this summary here, you will see that most of the processes, or all of the processes except the last one, goes under the planning life cycle stage. Okay, so it is under planning. So our work here is to plan for the schedule. Overall, we define the activities. What are the activities that we're going to do? And here we recall what we developed in the scope management plan. Because in scope management, we did the work breakdown structure. And in the work breakdown structure, we had activities, right? So it's the same activity list, but now we look at it from the time perspective, and we add more attributes related to time, okay? And also some resources, and we will come to this in the coming bad points, okay? Then we have sequencing activities. We need to sequence these activities. Now, when we list them in the work breakdown structure, we just had just lists, okay? So if I can do something, so you listed the items something like this, okay? But in sequencing, we will have something like this. Maybe this activity here, this activity here, this activity will start here, this will start here. The activities, okay? We will also cover this. There are things called the dependencies. Okay, we will cover this inshallah in this chapter. Then we assign resources for each of these activities. You need to assign resources. Okay, for each of them. Okay, resources can be like equipment, people, material, money. Okay, and so on. Then you have the estimating the durations. Now we know the dependencies, we know the resources, but we need also to specify the duration, how long each of these will take. Okay, each of these activities, how long it will take. We also decide this, and we have some methods or techniques to follow. Then you develop the schedule. This is the last step. You develop the schedule based on all of these information that you had. Okay, the activities, the sequencing, the resources, the duration. Then you put all of these into one complete schedule. We call this the development of the schedule, and this schedule will be your schedule. Remember, in the previous chapter, we said that we have a base. This will be the schedule baseline. There we had the scope baseline. Here now we have the schedule baseline, and this will be approved, and then you have to stick to this, and we will use it as our reference in the performance, because we're going to in the monitor the schedule. You will get work performance information, which is the actual time that you spent and related information, and you will compare it with this schedule, okay, the baseline. So let's take the first process, the planning schedule management. This task require some expertise. They will use their judgment based on their experience, and some techniques, analytical techniques, and they have to meet face-to-face or maybe virtually, and develop the schedule based on their experience and what available techniques. And sometimes you need to do some calculations to know the duration or some time. So this is required. Now, what do you include in this schedule management plan? You have a section in the plan, which is the SPMP. You will have a section that talks about the schedule, and one of them, or you have to explain the schedule model development. How did you develop this schedule? There are models of how to develop schedules, what model did you follow. Usually in organizations, they have, if you remember, the PMO, Project Management Office, they dictate certain methodologies and techniques to be followed in scheduling and planning and executing everything. They have their own methodologies, or they use or they follow one of the international standards available. So these 2 points, usually you have a method and you have to explain this method in this document. I also want to recall when I mentioned earlier that why do we do this? Why do we talk a lot, or why we write a lot of information in this document? Because these documents should be live documents, should be comprehensive, have all the information, because this is an organizational work. So you cannot depend on one person. Oh, okay, the project manager knows everything. He knows everything. Yeah, he knows everything. But if he leaves the organization, or God forbid, had an accident or passed away, then who's going to complete the work? No one knows. La? But when you document everything, you explain everything, it's very simple. You can just bring another project manager, experienced project manager, and he can read these and understand what's going on, and he can continue, so that you will get minimum disruption in the project. So this is the aim. Here we're looking at the project from the perspective of organization, because we want also to ensure that our projects follow some kind of process which will allow us to have quality work and also a continuous and sustainable business or work. Okay, so that's why we need to document everything. Then also you have the level of accuracy and units of measures. In schedule, we focus on what? For example, timing. Now you'll do a schedule. Are you going to schedule tasks based on the days that the task will be performed in, or by weeks, or by month, or maybe there are some projects you have to schedule things by hour, okay, or maybe by minute. So there has to be some guide for us, okay? What are our units of measures? Are you going to measure using hours, days, weeks, okay? And what accuracy are we looking for? Means the step from a unit to another unit is very accurate, that reaches to time, like hours or minutes, or just roughly 1 week, 2 weeks. So you have to also explain this. Control thresholds. This is also important to put in the schedule planning, because you need also to know what are the thresholds. And for example, some tasks need to be done, started and complete, and once started, you need to complete within 2 days, or maybe within hours. You cannot stay. Once you start, you have to finish. You cannot wait and finish the work another day, like in another day, or maybe on 2 or 3 days. So an example is like when you do when you are building a house and you are doing the plastering. So when you start putting the mortar and mix it, when you start mixing it, خلاص, you have to use it today. You have to do the plastering today, because you cannot keep the mortar for next day. خلاص, it will dry and then you cannot use it. لا. So you need to mention in this plan that there are some tasks, they have some threshold. When you reach to a certain level, you have to when you start, you need to finish it within certain time. This is one thing. Another thing is that you have a limit for you using or for doing these tasks. If I want to do in one of these tasks, let's say for example plastering, I can only work for let's say 4 days. I cannot go for more than 4 days, okay, because my employees, my workers will be available only for 4 days, okay. So all these things has to be mentioned there. Rules of performance measurement. Now, how we are going to measure your performance? Is it by by day, يعني completion of work at the end of the day, or by hours, or what, or something else? Okay, so these also need to be addressed. Reporting format. The schedule will be available online, or it will be printed and maybe hanged on a wall in an office, and then you can monitor it, or it will be sent through email, or you should also mention the reporting format, how you are going to report, and what is it that you are going to report back in that, present in that report. Process description. You also describe all the processes that you're going to conduct in the scheduling. If there are some specific procedure or process that you do to calculate the timing, duration, then you should mention this, explain it, so that when you put any figure there in the schedule later on for the duration, we know how, from where you got this, or what is the methodology that you followed, okay, to get these numbers. And also there we will have a section, or we'll have like a field to mention the calculation, or on which basis you decided the duration. We will come to this part when we reach to the duration process. So this is the planning. The defining activities. We already developed our task and activities in the work breakdown structure. So now we also add to it the duration and some of the resources and cost. So the cost is also, although it is another knowledge area, but also it is with us now. We also consider it at the same time. Because as we mentioned, you think of it as this is your brain, and there are some divisions there, okay? So all these divisions now work together to develop the work breakdown structure with all its duration and resources and costs. Okay, now the activities will be explained in details, and as we mentioned in the previous chapter. But here in time management knowledge area, we will list these activities, and we will add some attributes, activity attributes related to the time and resources. And this is an example. These are example of what you include. Okay, you can see here. Okay, this table here shows a good example. I'll just minimize this. Okay, this shows a good example here. You can see these are the activities. Okay, the name of the activity, and then you have description of the work. You have some description. These came from where? From the work breakdown structure. Okay, already we did this. So it comes here. You assign who's responsible for this work. Okay. Then if there are any predecessors, for example, these are has no predecessors because they are the start of the project, the first activity that you are going to do. But for example, 1003 has 1002 as a predecessor. So you have to finish 1001, 1002, and then you can start with 1003. Okay, and similarly for 1004. It is also dependent on 1002. We will come to the dependencies later. Also, you have the duration, estimated duration, and resources required. You can see here, this is for I think a computer. complete work area. Yeah, they are developing something, a center or something. So they have the network cables. They need network cables, new workstations to be placed, switches and signal repeaters. Okay, some trolleys to move things and recycling bins. Okay, so this is an example of what information you can add. Okay, milestones. We talked about milestones earlier. This is just another revisit to it. Milestones are significant events that happens without duration. It's just a single point of time, and it happens when you complete several activities at once. Example is, for example, obtaining customer sign-offs. Now, before we get the customer to sign the documents, key documents, as mentioned here, you need to do lots of things: prepare the documents, revise them, do this. So these are lots of tasks. When you are done from these tasks and the customer signs the documents, then you completed a milestone. And like this, completion of specific products. If you are producing 3 or 4 products, so you finish the first product, that's the first milestone. Second, then you achieved the second milestone, and like this. So the milestone is just a point of time on the timeline, and when you reach it, you are supposed to finish certain number of tasks. Okay, this is very helpful because you can see your progress. You can monitor your progress. Have you achieved milestone number 1 on that particular time? If not, this means that some of the tasks required to finish this milestone is not completed. So you go and you see what's wrong with these tasks, why this task is delayed, why it's not completed, and like this. Okay, so it's helpful to see the your progress. Sequencing activities, and from this diagram here you can see it's very obvious that how activities are related to each other. Now, dependencies are the relationship between activities. This activity starts before this activity, or this activity starts after finishing one or two activities or group of activities, and like this. It is very important to know the dependencies, because we will use something called the critical path analysis. This technique is used by the project managers. Now we will learn here how to do it manually, but in real life you will use the software, and the software will do it for you. But why we focus on it here? Because we want you to understand the concept, how things are sequenced in these tasks or processes. So you don't depend on the software. You can change the software, but you know the technique and you can do it. And even if you don't have software, you can do the calculations, and you can look at your project and see where are the critical paths, where you should give more, place more attention, and where you have flexible timing, and like this. So we will come to this inshallah now. Now, dependencies, there are 3 types of dependencies. One is called the mandatory dependency, and this is inherent in the nature of the work. You cannot do this because you didn't do the previous task. Okay, so this is hard logic, we call it. For example, if you have a can of soda, can you drink it without opening the can? So the dependency is mandatory. You have to open the can and then you can drink the soda. You cannot drink it without opening. So these are inherent in nature. Something that you cannot enter a car without opening the door. Yeah? You have to open your car door, and then you can enter the car. So that's a mandatory dependency. Unless you want to go through the sunroof, then that's something else. But this is the normal way. You have to open the door and then you enter. So the same thing in projects. You cannot develop say the software without having the entity relationship diagram, for example, or that's for the database. You cannot create the database without having the ERD developed. So this is a dependency. So that's mandatory. Some dependencies are discretionary, means that it is not necessary that you finish this to start the second task, but sometimes you prefer to put this dependency. Okay, and we call this the soft logic, and usually the team members, especially the developers, will know which task that they can that they can do it without dependency, but it is better to have it dependent on something else. Okay, because if they know some of the information about that task, it will help them to do it better. But here you have to keep in mind, you should be careful with placing these discretionary dependencies, because if you put a lot of them, then you will have less flexibility in your schedule. Okay, and the more dependencies that you put, the longer the project, and this is not something favorable for the project sponsors or owners. We need to finish the project as soon as possible. So it is optional. So be wise in using it. Don't put lots of discretionary dependencies. The third dependency type is the external dependencies. External dependencies are those who are not tasks that you depend on, and these are not under your control. They are not part of the project activities. They are something from outside. For example, I want to install, we are installing a new system, and we need servers, new servers. We ordered the servers. Now we plan to install the application on the server in April, in this month, but unfortunately what happens is that we have an external dependency, that we are waiting for the delivery of the servers in April, but because of the coronavirus, for example, issue, they cannot deliver it on April. They will deliver it on May. So here we have an external dependency. So our task to install the software will be delayed because there is an external dependency. We need to receive the servers first, and then we can install the application. So this is an example of how external dependencies work. Okay, it's beyond your control. You cannot do much in the delivery of something that comes from outside the project. Okay, now to create the now we are still in this sequencing activities. We are still under the sequencing activities. Now to show these dependencies and this sequencing of activities, we use something called network diagrams. Network diagram is a schematic display of the tasks with their relationship among each other. Okay, and it shows the relationship is any sequencing, which comes before which, and like this. There are the most common formats of developing these network diagrams are two. One is called the arrow diagramming method, and the second is called the precedence diagramming method. So keep in mind, we have two methods. One is arrow diagramming, and the second is precedence diagramming. Okay, now let's see what are these. The first one, arrow diagramming method, is we also refer to as ADM. We also refer to this method as activity on arrow network. We call the activity on arrow, AOA. Okay, and if you look at this diagram here, you will see that the activities, which are A, B, C, D, okay, and go on and so on. These are the tasks that you are going to perform, the activities that you're going to perform. And as you can see, they are placed on what? On the arrow. And this should be an this is not a good example. This should be an arrow because we have to know the directions. So all of these have some arrows. And excuse me for this. I chose this diagram, but I didn't notice that it doesn't show the arrows. But it's fine. Now you can see it. So you notice now that the activities are placed on arrows, and that's why they call it the AOA, activity on arrow. Okay. Now in this, you will have these circles here. These are called the nodes, and these are just the these nodes just show the beginning and the end of activities. So for example, node A is the start of activity A. So sorry, node 1 is the start of activity A, and it is node 2 is the ending of activity 2. So it's just a symbol to show the starting and the ending of activities. It's like a joint, it's just like a glue, okay, just to glue all the arrows together. So the numbering here, 1, 2, 3, 4, 5, doesn't have any meaning. It's just to show the beginning and the end of activities. The important thing here in this diagram are the activities A, B, C, D, and like this, and equal to, equal 3, equal 3. This means the duration. So A equal 2 means that this activity will require 2 days to finish, or 2 months, or 2 hours. I don't know what is used here in this example, but this is the duration. Okay, so we always place the duration against the activity. Now in these diagrams, we have these nodes that you saw, the circles. There are 2 types. There is the bursts and there's the merge. So if you go back here, so 2, for example, is a burst. Yani activity A is a burst activity. Why? Because from A you have 1, 2, 3 arrows coming out. Okay, so it's like an explosion. Yani they come up with this word as it explodes to 3 tasks. While if you look at the activity M, this one, this activity is a merge activity, where its node, starting node, will merge 3 arrows. You can see 3 arrows are merging in one activity, and this activity is called merge. Okay, so this is what it is mentioned here. So bursts occur here when a single node is followed by 2 or more activities, and a merge occurs when 2 or more nodes precede a single node. Okay. Now, how to create these activities and these diagrams? Well, I will have another presentation I will show, so I will just skip this now. I'll go to the second method. So this is the first method, the activity on arrow, or the arrowing diagramming method, ADM or AOA. Okay, now I know this is confusing, but you have to memorize them. Okay, then you have the second method is the precedence diagramming method. We also call it the activity on node. Okay, AON. We also refer to it. So activity AO. Okay. Activity on node. Okay, so look at this diagram here. You can see it's obvious now. The tasks, task A, B, C, now they are not placed on the arrows, they are placed on what? On the nodes, these squares. Okay, so we draw it in this way. We draw a square and we use it. Usually software, project management software, they use this method, the ADM. Okay. Now the difference between here and there is that now you have here a starting node and a finish node. And then you have the arrows. The arrows here just to show the direction and the sequence, the sequencing of these activities. So here doesn't have anything also, no meaning, and it just shows the direction and the precedence. Okay, so this is the PDM or the AON. Okay, memorize these. You have the ADM and the PDM. The ADM also referred to as AOA, and the PDM referred to as AON. Okay. Now let us go through what types of dependencies that we have. This is a good example. It shows all the dependencies, possible dependencies in any project. This is an example. It's good also to see. There is a dependency called the finish to start dependency, and it's very obvious here. A and B. So this means that finish to start. So B cannot start until A finished. Okay. So when this is finished, then this will start, and the arrow shows it very clearly. Okay. Start to start, and here B cannot start until A starts. Okay. So when A starts, then B will start. If A didn't start, then B will not start for good. Okay. If you don't start A, then B will not start. So this is the dependency. Then you have finish to finish, and this means that B can start before A or after A, but it cannot finish until A is finished. Okay. So it will continue in working. You will continue working in B, okay, until A completes, and then you can finish. Okay. So this task will continue running or open, will stay open until A is completed, and then B is done. So this is finish to finish dependency. Then the last one, start to finish dependency, and this means that B cannot finish until A starts. So this means that B is running and it will continue running. It cannot stop until A starts. If A starts, then B can stop. Otherwise, you will continue working. Okay. So these are the possible dependencies in projects. Also, you need to understand them and to memorize them. This is an example of activity on node, the PDM method, okay? And this is generated by software, project management software. I think this is from Microsoft project. As you can see, this is the activity here, activity name, okay? The date, when it will start and when it will finish, how the duration, it will be calculated because you know the dates. And then there is an ID for each of the activities. It has a reference number. Here, nothing mentioned, but usually it mentions the resources. Okay, so it will give you the resources that you require. This is a network diagram. As we said, it is an AON, activity on node, or PDM. Okay, and you can see the dependencies here. These arrows here. These show the dependencies. Estimating activity resources. This is the fourth process. Now here you assign resources. Now, before you start placing durations, you need to know your resources. You need to know usually what are the quantities required to do this task and this task. Okay. So that you know you can know how long it will take to finish. Okay, so you need to know your resources, what the available resources. You need to know the tasks or the activities required requirement from these resources, so that you can decide the duration. So resources here could be people, equipment, material. Okay, these are the resources that you're going to use. In considering the and estimating the resources, we need to consider these things. Ask yourself, how difficult will it be to do specific activities on this project? How difficult is it? Okay. If it's difficult, then you should consider the resources. You need, if the task is, or the activity is difficult, then you need to think of the people resource. Who's going to be assigned for this task? It's difficult. You need someone who's expert, who's smart enough, they can do it. Okay. In terms of equipment, if this is something difficult, maybe I can use some equipment that will make things easier for the workers or for the employees to do this activity, and so on. What is the organization's history in doing similar activities? Now, to estimate the resources that you need to look at, have we did this project earlier or this task before? Okay, how many people it requires, or how many material items it requires. So you can decide based on your history. Are the required resources available? This is also something very important. When you start scheduling and estimating the duration, you need to know if you have the resources or not, because sometimes if you don't have it, you need to schedule it in a time. You should have or place some time to wait until the resources reach your project site. Okay, so it's very important to know if you have it or not. So this will depend, or then this information will give you good decision about when schedule this task. Resource breakdown structure, and this is similar to the work breakdown structure that we did earlier, but that was the work breakdown structure is related to the activities, but here this is related to the resources. So you break down the resources into something like this. For example, you have people resources, you have equipment, and you have material. Then in the people, you have managers, you have maybe you can have system developers, system engineers, maybe quality assurance guys, and so on. Okay. For example, when you talk about equipment, you have, this example is for a tire company. So they have the tire racks. These are the equipments that they use. Then the material, rubber and whatever they use to manufacture the tires. So this is the resource breakdown structure. Okay, it's a hierarchy of the resources to identify and to categorize and classify the resources. Activity duration estimation. Now, when we know the dependencies, we know the activities, resources required, and the dependencies. Now we can decide on the duration, how long each activity will take. Okay, based, as we said, based on the resources that we have. Okay, if we have the resources, we can finish it quickly. If we don't have the resources, we need more resources, then it will take longer time. So it's dependent on the resources. So the duration, there are two important terms here related to duration estimation. There is a term called duration, and there is effort. What is the difference between these two? I can't remember if I explained this earlier, because in chapter 1 or 2, I talked about this also, but I will give another example now. Maybe it's the same example that I gave earlier. The difference between duration and effort. Now, look, take this example. If I want to build a room, okay, so I will bring the worker. Now, the effort that's required to build a room is 24 hours. And if I bring one worker, if he works for 24 hours, he's going to build this room. This room will take 24 hours to be completed. Okay, so the effort required is 24 hours. Okay, but does this mean that the room will be available in 1 day? Yani it will go, the worker will work and will finish it in 1 day, because we know that 1 day has 24 hours, right? So does duration equal effort? It's not. Why? Because you cannot keep the worker 24 hours working, right? The usual work timing is 8 hours per day. So this means that to build this room, you need an effort of 24 hours, but the duration will be 3 days. In 3 days, you can complete this room, because every day the worker will work for 8 hours. So 8 times 3, 24. So this is the duration. So the duration, 3 days, the effort, 24 hours. Okay. So this is to make it clear for you. So it's not equal. Duration is not equal effort. Okay. And you need to base the estimation on your experience. Okay, your previous work will tell you. Now, if I am construction manager, I know that this room will take 3 days. Okay, because I know that it needs one worker works the whole day, and it will take 3 days. He will finish it. So this from experience. We did this in many projects earlier, so I know that this is the duration and this is the effort required. Okay. The 3-point estimates, we call this also or we use this for to calculate the PERT chart, or to calculate the Monte Carlo simulations. The 3-point estimation is very simple. It's just you have 3 estimates. One is a very optimistic estimate. The second is, the most likely, in the middle, and then you have the pessimistic estimate, which is the worst in worst cases. Okay, and we use these 3 to do some estimations later. For example, if we go to this room building example, 3 days, this is the optimistic view, okay, optimistic estimate. If the worker is working completely 8 hours, okay, he's not doing anything else, this is the optimistic scenario. He will finish it in 3 days. But because he will take some rest, maybe 1 hour in the morning to have breakfast, then in the afternoon he will have also break for prayer and maybe for lunch. He might take rest a little bit after doing certain parts. Someone will call him to help in doing another work which is not related to this room, but in the same project. Again, this will be delayed. So normally we don't say that he will work 8 hours completely. So the most likely he will finish it not in 3 days, in 4 days. Okay. So now we have 2 estimates. The first is the optimistic. We said 3 days. Okay. The most likely, not 3 days. He will have rest a little bit. So you say 4 days. So, but maybe something goes wrong. For example, a rod fell on the on the worker's feet, and he got injured, something like this, and then he need to stop for maybe 1 day or maybe or more. So something might go wrong. So if this goes wrong, what will happen? طبعا we will be busy today to finish, to take him to the hospital, and then we need to bring someone else to finish his work. So I need to free up one person from another work, another task, and then give him this task. Okay, so there might be delay. We might go for 5 or maybe 6 days. That's the pessimistic, but not more than 6 days. Okay, so the pessimistic scenario is that if things goes wrong and we don't have workers available, then 6 days will be bad. We can do it in 6 days. Okay, so this is the 3-point estimation. Now we do, when we create these schedules, we create a table. We put these estimates like in 3 columns for each of the activities, and we keep them, and we will use them later for calculation. Okay, then developing the schedule, and here we take all of the things that we did in the previous process, and we start developing the schedule. The schedule will be in something called the Gantt chart. It will be something like this, okay, where you have the tasks and you have the duration of each task like this. And you can see these are the dependencies. These arrows are the dependencies, okay? This is just an example. So we have, if you look at these, this is another Gantt chart. You can see there are these diamonds, okay? And there is the summary task. The diamonds are the milestones. These are the milestones. These are the tasks, okay? The arrows, these arrows, okay, are the dependencies. And the gray lines here, bars, these are the task bars. Okay, these. Okay, so this is the Gantt chart, and it is developed after completing all the processes that we mentioned earlier, from process 1 to 5. Okay, yeah, okay, so you see these here. It is mentioned here also. The black diamond is the milestone, the thick black bar is the summary, and then they have the light horizontal bar is the duration, and the arrows are the dependencies. So all here, clear. Okay, the milestones, we talked about the milestones earlier. In projects, you need, especially when it's large, you need to have milestones so that you see parts completed in the project. Okay, you are completing the project piece by piece. Okay, and keep in mind that milestones has 0 duration, because it's not a duration, it's just a single point of time. Okay, it's not a duration, so it has 0 duration. These are just best practices. I just skipped them. You can read them later. Now, to track these, why we use the Gantt charts? Because we want to track our progress. Now, this is a tracking example. You can see here that these are the this is the actual activity, okay, with its duration. And if you look at this, the black bar, this is the actual, sorry, this is the plan. I forgot. This is the plan, okay, or scheduled task, okay, and this is the actual. Okay, so you can see there is a difference. This is the plan and this is the actual. The actual work took longer time than the plan. Okay, and what happens is that this, or let's say this extra time pushed the work for the next the following activity or task. So instead of starting here, it started here, right? So this task pushed this task, So this task, instead of finishing here, it finished here. So what happened is that we have, this is the earlier milestone, and this is the actual milestone now. So what happened is that we slipped the milestone. So this is called the slipped milestone. The white diamond is the planned, but the actual, we finished, instead of finishing in the, I think it's the 13th, we finished in the 14th. Sorry, in the 15th. Okay. So this is the how to read this. For example, this activity, there is no difference. Okay, there's no variance. It started as planned and it ended as planned. But these, you can see there is a difference here, right? So we have slipped diamond here, the same thing here. We have slipped milestones. And why we have, see, if you just slip one time, if you just exceed for one time, like here, let me change the color to white. So I've said, change the color to blue. So once you start this problem here, when you start having delay here, it will push this, this will push this, and then what happens is that this will be pushed. So the end of the project will be delayed, the complete project will be delayed just because you slipped one milestone. Okay, so this is very important. Now, in the coming slides, we will talk about the critical path. Okay, because it is not necessarily that when you slip some of these tasks that or milestones that it will delay the whole project. Okay, we will see this later. Like for example, this task here, it is not, there's nothing dependent on it. So even if you delay this for some time, it will not affect the other task. Okay, so this will be examined later. This is what I was talking about, is the critical path method. The critical path method, called the CPM, is a diagramming method or a technique that we try to find the earliest time that the project can complete. But also keep in mind that it is the longest path in the project. Now you have to think of this. It is the earliest time to complete the project, and it is the longest path through the network diagram. I hope this is clear to you. Maybe you will understand it more when you see the diagram later. Now, the activities on the diagram have some kind of flexibility in delaying. Okay, and we know how flexible this activity based on calculating the slack or the float. Some they call it slacks and some they call it floats. And basically, it is the amount of time the activity can be delayed without delaying one of the things, either without delaying the succeeding activity or the finished product time. Okay, and we will see there is something called the free float, and there's something called the total float, or free slack and total slack. There are differences between them. Now, how to calculate the diagram? Okay, to draw the diagram, it's simple. You place the activities based on the duration and the dependencies that you already identified, and then you will get something like this. You will draw this diagram, and A will have duration of 1 day or 1 week. Here it's days. Okay, so it's day, 1 day, and these 3 activities start the project. D has 4 days, and it starts after completing A, so then it comes after A. Here, for example, E comes after B. will start when D and E have been completed. Okay, so this is so this is the diagramming. Okay, so this is a project X. This is an example. So how we draw the activity on arrow? Always look at the questions, especially in the exams. Okay, we always mention the diagram that we are, the type of diagram that we want. Here it says AOA diagram. Okay, so what is the AOA diagram? We said activity on arrow. So the activities has to be drawn, and the activities has to be placed on the arrows that you are going to draw. So usually you'll get something like this. It says activity A, B, C starts the project. So you will draw something like this. Okay, A, B, C starts the project. And as I mentioned earlier, 1, 2, 3, 5, these are just numbering. It doesn't make any, it doesn't mean anything in the sequencing. Then activity D can start when activity A is completed. So D can start when A is completed. Then activity E and F depends on activity B. So here means that E and F will start after B. Okay, let me use the highlighter. Laser pointer. Okay, so E and F will start after B. Then activity H can start when activities D and E are completed. So when D and E are completed, H can start. Okay, and here we draw H. Then then G follows activity C and precedes activity. So G precedes C, and then precedes I and follows C. So this is, so in this way we are done from this. Yeah, there's one more. Also, activity J cannot begin. Yeah, activity J cannot begin until activities H, F, I are finished. So they have H, F, I. When they are all done, then we have activity J. So this is the activity on arrow diagram for project X. Okay, I think this is simple. So now we have a question here, and can you switch on your mics so that I want you to okay, so how many paths do we have on this project? Can someone tell me?
10 paths.
10 paths.
Sorry, can you repeat?
10 paths.
10 paths.
10 paths. Can you name them?
It is going to be as ABC until J.
To be as ABC until J.
A, B, C. Okay, now let me help you in this. Let me go to the pen. Okay. Now, the path should start from the beginning, the start of the project from here, and it has to end here. Each path has to start from here and end there. Okay. So we can say that this is one path.
4 paths.
4 paths.
4 paths. Yeah. Who said 4 paths here? Who was this?
It's Nasra.
Sharmeen?
It's Nasra.
Or Nasra, okay. Yes, Nasra, you are right. You have 4 paths here. How? We'll see it now. This is the first path. Okay? And how we write it? We say A, G, E, J. Okay, A, D, H, J. This is one path. Okay, the second, not working. Okay, I'll change the color. The second path is this one, this one, this one, this one. So the second path will be B, E, H, J. Okay. The third will be B, F, J. So B, F, J. This is the third. Then the fourth, we go for this. C, G, I, J. C, G, I, J. So we have 4 paths. Is this clear? You know how I did it, right? So once you start from the first node, you have to continue until you reach to the end, and you have to cover all of the paths. So this is the path. So we have 4 paths, and these are the paths. I'll just minimize this. Okay, as I mentioned here, it's ADHJ and BEHJ, BFJ, CGIJ. Okay, now, can you tell me which is the longest path here? Can someone guess which one is the longest path? Anyone? Hello?
I think all are
H will be 1 and B F and B E H J.
I didn't hear you. First we said what? B?
BEHJ.
You say that this is the longest. Okay. And your colleague said, who's the other girl? She said also something. Your voice is not clear.
They are
Can you
equal.
raise your voice, please? They are equal. Okay. Well, actually, we cannot decide which one is longer because we don't know the duration of the activities. Do you know what's the duration of the activity A? We don't know. E, F, H, we don't know. And the length of the arrow doesn't represent the length or the duration of the activity. It's just a diagram that we draw them just to keep good space between them. We do some of them longer, some of them shorter. So based on this given information, you won't be able to know the duration of the project or the longest path or the shortest path or whatever else, or even the critical path. You cannot know this. So what we need more information to be able to calculate. So here in this example, they gave us the duration of each activity. We can calculate it, and it's very simple. In front of each activity, like here, we place the duration. And since we already identified the paths, remember this? We identified it already. So now we just substitute A equal 1, D equal 4, H equal 6, and J equal 3. So you add these and you'll get the total number of days, which is the length of path number 1. Okay. Similarly for path number 2, number 3, number 4. Is that clear? Okay. So now, where is the longest path? Actually, this is I circled this, but this is not. So where is the longest path? It is path number 2 because it has 16 days, right? So this is the longest. And in projects, in the network diagrams, the longest path is called the critical path. Why? Because if you increase in 14 days here, if you increase 1 day, it will be 15 days. Still, you are going to finish after 16. If you increase in path number 3, you made it 10 days. Still, you are going to take 16 days to complete the project completely. So 16 is the longest path. That's the critical. But if you change something in this path, in the path number 2, and any delay happens in path number 2, then the whole project will be delayed, and that's why we call it critical path. Now, what do we mean here? Or let me give you an example. Now, this path number 2 is the critical path. What activities is on this path? B, E, H, J, right? So if I come to activity A, okay, which is not in the critical path, and I delayed it by 1 day instead of 2, it became 2 days. What will happen? You will add here 1 more data, so it will be plus 4, plus 6, plus 3. It will be 15 days, right? Still, the date would be 16, and after 16 days, you will complete the project. If I come to any of the activities that are not on the critical path, it will not be affect the project. طبعا to a certain amount. يعني بعد حطيت 20 days on activity A, so definitely it will push the project. But I mean 1 or 2 days. But when I come to B, and instead of finishing in 2 days, I finished in 3 days, what will happen if I come and substitute B here? 3. So it will be 3 plus 5, 8. 8 plus 6, 14. 14 plus 3 will be 17. Is that correct? Yeah. So the date, the path will take 17 days to complete the project. Okay, it's not working. I have some trouble with my. Yeah, let's try again. Okay, so this will be 17 days. Okay, so any change on the critical path will change the project completion date. Others, well, it depends, and we will see this. Okay, so this is the critical path. Okay, can a project have more than one critical path? What do you think? Can we have more than one critical path?
Yes.
Yes, we can. We might have 2 critical paths. Okay, so yes, we can. Okay, another question. Can the critical path change? Now the critical path is path. Can the critical path change to another path? Can path number 4 be the critical path?
Yes, if we change the duration.
Yes, it can change. If we have lots of delays in activity C and G, then we might go for more than 16 days. So then the critical path will be number 4, not number 2. because we said that the critical path is the longest path. So it has to be always the longest. Okay, so I think we need to stop here now. Next time we will see how these changes happen, or how these delays affect the project, and how flexible we have, or what are the activities that have more flexibility to be delayed, and which are the least flexibility to delay. We will cover it inshallah next class. So I'll stop here now and